Hello, everyone. Welcome to Foresight's Computation Group. Today, we're so excited to have Anders Sandberg here with us. He's a researcher at the Institute for Future Studies in Stockholm, but really needs no introduction. So today we have Anders here with Law, Liberty, and Leviathan. Thank you so much for joining, Anders.
Well, thank you for having me here. I'm going to turn on a bit of screen sharing, but as you might guess, this is the result of my project on a book writing project that began in 2020. During that time, my friend Cyril Holm, a professor of jurisprudence, was guest professor at Christchurch, which is normally a very plum position, except this was 2020 and it was lockdown. So we ended up shouting research ideas across my garden at a socially distant distance, thinking about, well, whatever. So we were kind of considering pandemics, existential risks, and government interventions to deal with them, how much humans need each other and coordinate well, and what role does AI have here? What about things like Nick Bostrom's concept of singletons? So we started riffing on that, and that resulted in this book. And as of this week, the publisher, Stockholm University Press, has decided that, yep, we're totally going to print this book. So now I'm in the last rush of actually getting everything right. So there's still time to fix glaring stupidities, but it's also putting me into the slightly annoying read my book mode. So I love to discuss with you some of the ideas, and especially how they might interact with intelligent cooperation, because deep down, this is all a book about how do we do cooperation now and in the past, and how might we do it in the future, and can we do something smart about nowish to get that cooperation to work out much better. And generally, I think if one were to try to summarize this entire book into three things, it's that law and social norms are best understood as a kind of distributed cognitive architecture. It's kind of nature's solution to the cooperative coordination problem and is powered by human autonomy. I think this is not a radical claim in this group. I think most of us have internalized that. There's a surprising number of other people, especially scholars in law, that don't buy this, and we spend a lot of pages dealing with that. The interesting thing is, of course, that AI might threaten to make this architecture obsolete, and that produces what we call the Stom Conclusion, which is, of course, a riff on Friedrich Hayek's The Road to Serfdom. Cyril is a Hayek scholar, and I had personally removed an endless amount of Hayek puns from the text, but many of them are still lurking there. So even with perfect alignment, we might end up with a situation where our architecture gradually gets replaced with a kind of software system where human autonomy is not needed. And that might look rather threatening. And there is an interesting question, why is it threatening? And finally, of course, what do we do about that? And I think there is an interesting thing we are talking about, but haven't developed super deeply. And I have a feeling that you guys might help develop into a really good theory, that there is a kind of precise crossover point between where decentralized autonomy wins and where centralized coordination becomes necessary. And finding that one might be the most important design problem. But it might also be a really intricate problem of figuring out how to find it, or even whether it might be observable in practice. But anyway, let's get on with the basic story. So human social nature is kind of an interesting one, because we are rather stupid. We are social beings. We don't survive very well on our own, so we need each other. In order to function together, we need to coordinate, and we have amazing powers of coordination. Certainly other animals form flocks and schools and other social arrangements, but we tend to form group intentions. It's really something magical. So chimpanzees can go to war against each other, but typically that is that a group of them meets another group and they hit each other. It's kind of a situation turns violent, and then everybody copies everybody else and you get a fight. And then somebody wins and somebody loses and territories change because of that. We humans, our ancestors could sit around the campfire and discuss, what are we going to do tomorrow? Should we hunt the rabbits, or should we go for a mammoth? oh, and we're all rather hungry, and we realize, yeah, maybe the mammoth would be the solution to all our problems. Let's go for the mammoth. But that means that now we need jointly to coordinate about it. So we both have this joint idea that we're going to do one thing and not others. Next morning, if somebody goes off hunting rabbits, we're going to look at them rather negatively. We decided, after all, last night to go for the mammoth. We might also use our language ability to coordinate. So we come up with a plan that some of us go via the forest and try to scare up the mammoths. Others are hiding behind the hill and so on. And we can even do clever things like decide on how to share the spoils. We might say that, okay, the equal shares for everybody, or maybe the people taking the risk and getting up close, they get to choose first or something like that. And then next morning we go off and do that, if everything works. And the next evening, we're going to eat a good fill. The interesting thing here is that we have set up the joint interaction, and the poor mammoths can't understand why these weird hairless apes show up from different directions as if by magic, as if they knew what would happen. And also they have prepared things ahead of time. This is, of course, partially you should be able to say this is just intelligence. But intelligence is not enough, because it's really hard to predict people's actions. And we are still pretty stupid. It's fairly easy to mess things up. So you might have told me very clearly that I should be behind the hill, but I think I should be behind the rock because I'm hearing a little bit badly, or I didn't pay attention well enough. Or we might be selfish. Many of us want really big pieces of meat for our families that we would like to have more than our share. Yes, it's good for the group, but my stomach is telling me that I should get a bigger share. So we have an incentive to defect. So the cool thing here is that we solve this by building up these institutions, rules, and norms. And quite often they become really interesting conventions. We quite often have conventions which are arbitrary things, like which side of the road to drive on. But these conventions then become habits. It's very easy to follow it. And we tend to follow rules. We are very normative animals. If your parent tells you very with a stern voice that this is the divine command on how we're doing this, or you've been told that in this tribe we always have a ceremonial mammoth hunting dance once we decided, and staying out of it is not an option, we're going to take it much more seriously in many ways than a statement that, yeah, there is a lake over that hill, or the capital of France is Paris. We treat normative things as special and something that should give us a motivation. Now, this is the point where, of course, philosophers get all deep into ethics. And our book is kind of cheating by trying to use error fear. We're trying to ignore ethics altogether. We're basically given an argument for why ethics might be totally bunk. But these normative things are important, sticky, and helps the tribe get the mammoth. And then later on, as we try to explain why certain rules are what they are, we develop ethical theories, which might even be good theories. But the practical thing is that they help organize us and give us peace and prosperity. Many of these things are fairly simple. So we call them PEGs, pragmatic epistemic guidelines. So very basically shortcuts that capture solutions to coordination problems. And that might be, for example, like that we have a rule for how we vote about what to hunt. And that rule is somewhat traditional. And we know that if we follow that rule, things go generally good. A beautiful example is a queue. So queues are having this interesting property that they are sticky. We even treat them as somewhat normative. You could say it's rational to do a queue. It's a way of allocating access. But actually, we treat them very differently. Every September, out here on the road here in Oxford, we see a little drama when the Italian students arrive and are queuing at the bus stop. The rest of us are standing there in a very strict British queue. The Italians saunter in and ignore it. Oh no, we are feeling very annoyed in a very British way. Of course, very few people are saying anything, but we are thinking bad things. And we're standing there in a very demonstrative queue. And by December, the Italians are standing there in the queue with us in the rain too. Why? Well, it's not just that a queue is a rational thing to do. And it's not just that we humans imitate each other a fair bit. It's also that the slight frowns, the slight edging of elbows in the direction of would-be queue jumpers, that's already enough signal to tip off some part of our brains that maybe there is a norm I'm breaking here. And indeed, anthropologists that have been studying queues, they observe that planning to do queue jumping for science is stressful. Many of them actually note that they feel nausea. That was Milgram, who is kind of infamous for his obedience experiment, but even he felt like, queue jumping? No. And the interesting part here is that this shows that we use this normative system. It's not just the pragmatic epistemic guideline. It becomes something that is tied to the more stronger mechanisms. And we call these more advanced ones precepts, that they are a system that are prescriptive. And they emerge, of course, in an evolutionary fashion. Sometimes people decide on doing something deliberate, but quite often it just happens. Queues, for example, have shown up independently in different places. During the French Revolution, there were bread queues over in Paris. And the British historian Thomas Carlyle was writing about them, was astonished about this weird thing. They're standing there in a line waiting for the bread. How quaint. We're never doing that at home in England. The British queue seemed to have evolved very much during the shortages during the Second World War. But then, of course, persisted, because now we have a queue system and we imitate it. There are alternative queue systems, like the El Ultimo system that emerged from Cuba, again because of scarcity. But then it spread to various Latin American countries, and apparently it's shown up now in Los Angeles too. It's based on a different setup where you just ask or are pointed to the previous last person, so you know who to look for. But you don't have to stand around in that stupid line in the rain as we do over here in Britain. So this generates this interesting behavior that solves coordination problems really well. And of course, on the larger scale, the legal systems are like that. They declare standards for actions and outcomes, evaluate them as good, desirable, permissible, bad, and we coordinate. And the cool part here is, of course, that this coordination works really well even when they're not explicitly enforced. We tend to obey laws and rules even when there is no policeman in sight. In fact, a rule of law system requires everybody to know that everybody else knows that there is rule of law, and that you can roughly trust the courts and police and the laws in a certain way. And that means that you expect everybody else to behave like that, and you expect yourself to behave like it. So this is interesting. It's not really radically new. We put some new labels on it, but the end result is that we get these extended cognition systems. And that is quite cool. So many of you have probably heard about Chalmers and Clark's extend the mind hypothesis. The idea that Otto, who has got Alzheimer's and has his memory shot, uses a notebook to note down where he's going tomorrow and how to go there. And they argue that we should treat the notebook as part of his mind. He's got an extended mind, and we extend it using tools. There is an interesting question here for philosophers of mind, whether it's actually consciousness embodied in the notebook, etc. For our case, we only think about cognition. And there are these interesting debates about, is there actual group cognition? And I think it's pretty clear that there is. A forensics team working on a crime scene, not everybody knows every method being used, but they take their different roles, they gather information, it gets collected, and a joint picture of what happened emerges from that. And running a big boat or a ship requires a lot of people doing different functions. There is a distributed cognitive system across the crew that actually allow them to be aware as a collective about what's going on. Some people are doing the lookout, some people are tending the engines, information is flowing between them. So these collective mental states and beliefs, I think, are really important. And this is, again, something that emerges rather effectively among creatures like us. And this allows us to do really amazing things. And this, when it works, it gives us a lot of peace and prosperity. The problem is, of course, that selfishness part. So we do have some people who might want to exploit this. Oh, people in the tribe have rituals and rites. Maybe I can just make up that actually the gods told me something like this. Or maybe we can make a special rule and claim that, oh yes, the ancestral spirits always want people with names early in the alphabet to get a larger share of the catch or something. Or I just find a bunch of big brutish people and beat people up until everybody celebrates me as the local king. There are different ways of doing it at different levels of sophistication. Now, it's kind of an interesting thing that what happens here is that now you might say that breaks the system. This is going to destroy it. And a stupid bandit does that. A roving bandit coming in, kind of pillaging the village and burning it, destroys the social fabric and is generally inimical to everybody. But then, as Manker Olson pointed out in his theory of state formation, actually, quite often bandits need to winter over in the little village. And at that point, it's stupid to burn it down because you want to stay there, at least for winter. And the villagers, they're not particularly happy about you taking their food and the stuff. But on the other hand, you have a reason to keep them alive. You don't really want to wreck the thing that actually gives you food and shelter. Even worse, there are roving bandits out there. You need to actually get the villagers and your brutish friends to head them off because you got a good thing going here. And quite often this extended system hence start winding in the people trying to exploit them. The sociopath might be very good at getting to the top of the organization, sometimes by manipulating rules ruthlessly. But once you're close to the top, you really want those rules that give you power enforced. You don't want sociopaths to take over too much. You want the rules to be fair and square, at least in regards to everybody else. So I think what is happening is that we quite often end up with these structures that are pretty resilient because there is a fair number of sociopaths and selfish people and people just trying out how much you can break the rules, testing them. And many organizations then develop almost like scar tissue rules and norms against that. Cool. I need to hurry up, but the end result of this is, of course, what we end up with really big systems. We call them guides, globally unique decision entities. They can be very big and very complicated. And we're living inside these enormous cognitive artifacts. And there are things like states, markets, legal systems, and quite often they follow what I would call a Highlander prism. There can typically only be one per domain that we're talking about. It's not strictly true. For example, here in Oxford during the Middle Ages, we actually had two legal systems, one for the church and one for common people. And this led to endless friction and a lot of the bloodshed in medieval Oxford because the students were technically under the church. So whenever they did something naughty, they were hauled off in front of a church court, which generally tended to treat them rather nicely. And the commoners were in front of the crown court, which generally tended to chop off their heads or treat them very harshly. This was pretty unfair, and that is why there is so many riots in medieval Oxford history. Eventually, of course, running two legal systems side by side created enough friction that actually they joined up and became one. And this is typically what happens in most places. David Friedman has this brilliant book, Legal System Very Different from Our Own, that describes a lot of other cases where you have parallel legal systems running side by side. But in many cases, the requirements for keeping them separate are quite extreme. In general, the Highlander principle gives you economies of scale. If you have several different markets and you don't join them up, people will try to find arbitrage by linking them, and eventually they tend to merge together. So there might be these very big sovereign ones, like Hobbes' Leviathan, the sovereign power of a state, or Nick Bostrom's idea of a singleton, a hypothetical future state that can run the world. We also have the designed guides sometimes, like constitutions and regulatory bodies, and then emergent ones like markets and many of the normative systems. Many legal systems are way more emergent than legal scholars would like to admit. But this is not a grandiose claim maybe in American England, because common law kind of admits that a lot of the legal precedent is about the rules inside society, and we try to embody them. But over in Sweden, this is actually a rather edgy claim, because the civil law system we got there at least on paper, everything is coming from Parliament. They should be deciding the laws, and judges don't have that much leeway in how to apply the law. Except that in practice, prosecutors and judges adapt all the time. There's an obvious adaptation to what actually works that is going on there. And sometimes the friction might be big enough that the government changes the law. Quite often it's about the praxis, including the praxis of who do the police catch and for what crimes. Now, the key insight here is AI governance is not discontinuous with the existing coordination mechanism. It's on a spectrum. Since we are already arguing that we have a system that aggregate, distribute signals and coordinate a lot of agents and solve computational hard problems, and they're doing that as a form of extended cognition, then it doesn't seem that weird that you could run some parts of this on software. Otto's notebook is kind of a quaint example because the paper is from the 90s. Today, of course, Otto will be having a smartphone. And most likely the smartphone might actually have software doing actually active things. And I think it's pretty obvious that we are extending a lot of cognition into software. So we argue that there is a kind of continuity thesis here. And that means that when we understand how existing coordination work at a computational epistemic level, we might actually learn interesting things about how it both might be extended or replaced or maybe cyborgized with software. Okay, some people of course think that these naturally occurring systems are really nice and all, but in many cases they're unfair or inefficient. So maybe we can do it better. So one form of failure mode is a little bit like the book Seeing Like a State describes, where you come in, you notice a lot of quaint practices, and you say, no, this is irrational, let's do it in a rational way, and later it turns out to be a really stupid idea. Why? Well, as Elinor Ostrom demonstrated, a lot of these weird local practices do contain a lot of information. Those complex rituals about what fishermen can sell what fish on what day on the east coast of India actually act as a distribution mechanism, making it fair for everybody. But it looks like a kind of weird custom. So when the government moves in and says everybody can sell on every day because it would be weird discrimination, otherwise they actually might break a coordination mechanism. Another and much more grandiose problem is, of course, the idea of centrally planned economies that socialism did. In order to reduce unfairness, the idea was we can rationally design a market. And since we can rationally do this, we can probably do it super effectively. And the problem with this is, of course, as the classic socialist calculation debate in the 20s led to, but von Mises pointed out that, well, if you don't have any prices, that reduces your ability to coordinate. And Hayek pointed out, well, you need the individual freedom. It's a necessary instrument for maximize aggregate computational capacity, which you use for maximizing the utilization of this distributed knowledge that exists. You're not getting the information together in that central planning unit. It's going to make the wrong decisions, not have enough data. And of course, at that point, you don't get a rational allocation of resources. Now, at this point, of course, the socialist says, just watch us. We're going to produce kind of red plenty, which instead turned into bread queues. It didn't work at all. And this was not because they're malicious or stupid. They really tried that gospel. And indeed, they developed various forms of cybernetics. And the ideas of linear programming partially were invented in the East Bloc in order to do this rationally. And the cool thing about linear programming is that from a computational standpoint, we know that this is polynomial. You can solve a linear programming problem, assuming the economy is like a linear programming problem, which it isn't. But let's assume the best case. So at this point, my fellow theoretical computer scientists would say, oh, polynomial time, wonderful, this is tractable, we can do this. Except that it turns out the exponent is big enough that it takes about 540 million years to actually allocate the goods in the world economy, and something like 50 million years for the UK or something like that. So even for the smaller Soviet economy, this didn't work. It didn't help that we didn't have good computers and that they were bad at coordinating and linking up the computation. So the cybernetic system, OGAS, the all-state automated system, failed because of rivalry between different departments. It's kind of an irony here that in competitive America, people were very willing to share the early internet. ARPANET was extended to universities and other institutions very openly and freely, while in apparently solidarity around the Soviet Union, nobody wanted to share the computing. So this actually mirrors an argument Pareto did theoretically back in the 1910s, where he pointed out that more than 15,000 equations in the economy, if you want to optimize it, and you can't do that. There is not enough pen and paper. So this is, of course, the point where I, as a smug liberal or libertarian, say, oh yeah, and that's why socialism doesn't work. Except that now my cyber-socialist friends will start digging up a whole bunch of theorems and embarrassing things from the textbook too. Because there is actually, in principle, same argument for intractability of market. Price formation, you can show that should take exponential time. Why? Well, you can set up various production and utility functions, and the worst case performance means that it takes a lot of time. But when I bought my coffee earlier today, that price had settled without taking millions of years. There are multiple equilibria in the economy, which breaks a lot of the nice theorems economists like to use. But obviously the economy still works. In practice, it worked really well. And the answer is, of course, yes, distributed computation, and it approximates things. Mises and Hayek are kind of smiling and saying, yep, that's why they work. Now, one interesting thing here is, of course, that if we start thinking about superintelligence and AI, this leads to an interesting question. Would a superintelligence be able to run the world market? And Mises and Hayek would say, absolutely not. It cannot centralize the information in the right way, and that's why the market is always going to be smarter than the superintelligence. This is a really cool, bold claim. I also don't really believe in that. Partially, of course, because you can try to cheat in various ways. So there are various cyber-socialists that realize that actually centralized economic planning doesn't work, but we can do decentralized economic planning. We can actually imagine splitting the economy into pieces that are modular, and that means that they actually can function better. So there are some like Paul Cockshott who does believe that his algorithm actually works, but I have arguments that no, it doesn't. He's solving the wrong problem. But there are others that do recognize that you can actually do market for some things, but not others. And this is also demonstrated by Walmart. Walmart is larger than quite a lot of nations, and it has an internally planned economy. So why does Walmart work? And one reason is that when you set up a new Walmart store, basically they probably have a wizard on the computer where you kind of check various things. What size is the store going to be? What outside the coverage is going to be? What other features does it have? Basically, they have made modules that you string together, and at the end, you presumably get a blueprint and an Excel spreadsheet about what you know, who you need to hire, and what you need to do. They have basically split the problem into some simple modules that are in some sense solved. They work pretty well. Then they can get local adaptation once they're up and running. You also have a system that it acquires a lot of information about what's being sold. Walmart was very early on taking all the sales data, putting it together and do a computation. Excuse me one moment, I think I got a letter. I think it's the market delivering something. One moment.
Oh, no problem. No problem. No.
It was not the market, it was my neighbor, and she had locked herself out. So now I, of course, followed the proper social norms and let her in. And the cooperation in the house is going to keep on going well. Now, the interesting thing about Walmart centralizing information is now it can run a planned economy, but it's simplified. It's factor things. And this is where I think when we get to AI being powerful, we get an interesting possibility. It might also be able to factor various markets and problems in ways we cannot see or easy to factor. You might lose something by this factorization, but you also gain a fair bit. So Coase famously developed the theory of a firm way back in the 50s, where he pointed out that transaction costs are the reason we are not just all independent agents. It makes sense for us to band together in an organization because that reduces transaction costs. And these organizations then grow up to a limit set essentially by the economies of scale. Beyond a certain point, it becomes ineffective. Herbert Simon both a pioneer in economics and AI, pointed out that actually the world is full of planned economies and it's only a little bit of market between them. These planned economies are the corporations. And the size here of these systems depend quite a lot about this balance between these economies of scale and transaction costs. And Sara Hidalgo later on did complexity economics, kind of putting it into a more modern internet-centric framework, but it's basically the same. And again, the internal organization is also about managing these information costs. You don't want to have too much complexity, so you create the compartments and departments and ways of transporting information. Now, if we get better AI, we might then change the economies of scale and the transaction cost. It's not entirely obvious to me whether this leads to a situation where you get economies of scale, but suddenly mean that Walmart becomes 100% of the world economy. And the cyber socialists and us liberals are standing there saying that's not what we wanted. Or maybe you get lower transaction costs. So instead you have a gig economy where everybody is a free agent being helped by a bunch of AI systems interfacing them with the market. Now, most likely that low transaction market is probably better for AI agents than humans. Humans might actually have a hard time thriving in that kind of structureless environment, while the agents might be happily just churning along very quickly. So the really interesting thing here is that we might end up with very different economies, and it's hard to predict. Okay, existential risk, I probably don't need to talk too much about it. After all, I'm originally from the Future Humanity Institute, and doom and gloom is the main trade. The really interesting thing about existential risk is, of course, that it's a good reason to coordinate because we don't want to go extinct. We want to give that priority, and that means that we need to coordinate better. But it's also pretty obvious that the existing structures are pretty bad at coordinating against some things. We know governments can just barely handle a relatively mild pandemic. A really bad pandemic is a very scary thing. Nuclear war, again, in some sense, we have had a coordination mechanism against it, but it might become more problematic the more nuclear powers we get. And the interesting thing here is it's hard to grow these epistemic artifacts when a single mistake is terminal. So you might have to actually design them. And this is, of course, where the current anarchistic world order looks really unable to handle the threat. And serious concerns about things like AI might also mean that, we need to coordinate against AI, but we might need AI to develop a better coordination mechanism. So Thomas Hobbes' Leviathan is kind of a classic touchstone. That frontispiece is, of course, what I was riffing on my first slide. It's super famous, and it's an interesting outgrowth of a long tradition of thinking about the embodiment of groups of people. Again, long sidetrack about what the body politics mean. It's super cool, but I don't have the time for it. But his argument, written, of course, just after the British Civil War, was without coordination, life is nasty, brutish, and short. It's better to even have a tyrant running things because that coordination helps us. This was already suggested by Dante Alighieri way earlier in his De Monarchia in the 1300s, that the well-being of the world requires that there be a monarchy or an empire. And this is, of course, the classic idea about we need coordination to handle it. And then people might imagine various ways of dealing with it. The problem when you get to the idea of a world government or Bostrom Singleton is that, cybernetics start to bite really badly. Basically, if you want to control a system, you need to have more degrees of freedom than the system itself. That is Ashby's law of requisite variety. And whenever somebody cites that, it shows that they're not up to date because that's super early cybernetics. This is 1950s cybernetics before we even had the concept of information. Variety here really is degrees of freedom or bits of information. But you can turn it into the good regulator theorem or in the more modern form, the internal model principle, which is part of standard control engineering. A control system needs to contain something equivalent to a model of a system it controls in order to control it perfectly. And that is scary if you want to control the world, because now the controller needs to be bigger than the world. So One approach is to accept this and say that, yep, we need a coordination mechanism that just needs to be growing faster than our world. If we leave Earth and go to space, it needs to come with us and grow even bigger. So eventually humanity might be this little crystal inside this vast protective singleton infrastructure. Or, and this is more and more dystopian thing, it prevents the growth of that complex thing it wants to control. And this is typically, of course, how many totalitarian governments behave. Limit what people can do, and then they can't do anything wrong. And then, of course, human well-being starts getting thrown out. The second way of dealing with it is, of course, say, not everything needs to be controlled. We might leave some degrees of freedom. If you have a singleton that prevents nuclear war and the people stockpile nuclear weapons, it will only look for radioactive materials, and it will leave everybody in peace in all other dimensions. That might work. We might accept having a Geiger counter in every room, even in the bedroom, because if you're really concerned about a Geiger detection in the bedroom impairs your privacy, you're doing something really weird in your private home. I think in general, the problem with this limited thing is, of course, that what if somebody tries to come up with a cork bomb or something else? That singleton system needs to be able to actually look at emergent new dimensions of problems. So it's probably not going to stay in just one domain, which is, again, a typical libertarian critique of the government getting various powers in order to safeguard us against a threat, because typically they soon gets extended to safeguard us against other threats and things that the government thinks is a threat and just a good thing to safeguard against or just regulate or keep an eye on. It tends to expand. And the third way out is, of course, to accept that singletons are not perfect and sometimes they fail at the task. So the whole problem is, what kind of global coordination can we accept? Now, the big point we're making is that suppose we fix AI alignment, otherwise this question is moot, then we might end up with a world that is actually run by AI almost completely. Because we are likely to start using the agents, we're starting to mediate our sociality. It's partially because we use software to mediate things. Most people today are dating somebody because of apps rather than naturally running into each other at the work or in church or something like that. And we're getting exoselves like our little smartphones. And of course, we might soon have lawyer bots. Basically, AI creeps in because it's so darn useful. And we might also have a robot bureaucracy creeping in from above. Right now, increasingly, people are using AI to write letters and emails and reports to the government, and various bureaucrats are responding by using ChatGPT to read them. And we might see more and more decision-making in administration moving over into AI. Again, this is very much in line with Max Weber's ideas about how we get this gradual rationalization of bureaucracy. He didn't know anything about computers or AI, but he would just say, oh yeah, this is exactly what I was talking about. I just believed it would end up with total bureaucracy, but now I see that we get a bureaucracy made out of software instead. And of course, we might also have a situation where people actually hand over power to AI. That might sound totally crazy, but there's certainly enough people actually thinking technocratic rule is good. And unfortunately, there is also discussions about gradual disempowerment and AI-enabled coups that suggest that, yeah, various people might get tremendous power because of AI if it centralizes power. And if they sit on that power, now they get to run stuff. The problem is, of course, once you have that power, you're dependent on the AI infrastructure under you, reporting to you, telling you what's going on. And now you're going to be in its epistemic system. It's going to tell you what you need to know in order to run the world. And after a while, I think what is actually happening is it's the system running the world through you because it's smarter than you. So the Industrial Revolution decoupled work from muscle power. And AI doesn't just decouple cognition from human minds, it also decouples autonomous action from human autonomy. And that might plausibly amplify our ability to get desirable actions done. But it also makes human decisions as irrelevant as human muscle power in many processes. So this is where you might end up with what we call the Stom Conclusion. Basically, we get way more peace and prosperity because we have our AI systems that are really good. Again, I'm assuming here that alignment work well enough that there is a world and it's not just collapsing or turning into some automated bureaucratic system that doesn't work at all. And it's interesting because this is not that autonomy is bad. It's just that autonomy becomes irrational. It's a little bit like choosing to navigate by the stars when you can have GPS. You can live in a cabin in the woods with no electricity, but not that many people would be willing to do that. And most people who do, they quickly go back and write a blog about it and they don't return. So if this conclusion holds, individual autonomy might gradually become similarly inconvenient. And that leads to this weird situation that, okay, we're losing autonomy, but many might be rather happy. When I asked on Twitter, about 75% of my followers said that they would be happy to be pampered aristocrats in a world run by benign AI. 25%, however, said, no, absolutely not. We want to be in charge. And it's an interesting question. Why do some of us want to be in charge of our lives? So in this book, we have been kind of not using ethical arguments. We're running on error theory, which I don't believe in, but it makes it interesting. But this is the point where it really bites. Because most ethicists would say autonomy is super important for how we work as moral beings. So that is why autonomy is important. It's almost a given. It's almost axiomatic. But I think one can also give a practical psychological argument. It's not intrinsically valuable, but it loses its instrumental value in this AI world. But there is a desire for autonomy. And I think we have a Darwinian case for that. All our ancestors that didn't feel any need for autonomy, they got exploited ruthlessly by others. They didn't leave that many kids. You need to stand up for yourself to actually find a mate and actually get a life that somewhat works. We have evolved to have a desire for being in charge enough about our lives. So we want to have a well-grounded feeling of being in control of one's life. And this is really important for emotional well-being. There is a reason why so many people feel much more afraid in an airplane where we don't have much control versus in a car where they have control, although it's way more risky. So it's our kind of creature that needs it to flourish. And in that case, we still have a good reason to do it. It's much more deflated from some kind of high-faulting philosophical argument that autonomy is essential for human dignity and human dignity is all. But I think it's pretty obvious that we would not function well without it. Then again, we trade our autonomy all the time. I'm married. I'm very happy to be married, but that has reduced my autonomy in some respects, but I'm getting something back from it. By working for a company, you give up some of your autonomy, but you get paid and you might get other perks from that. This trading of autonomy is kind of that works rather well for us. As long as we think we get doing fair trades, this works. Okay, so what can we do about this? So I'm totally running out of time, but I think one answer to this might be that actually maybe those 75% of people were totally right. If we just get an abundant future, everything is fine. A lot of the problems in justice, as Hume pointed out, actually go away if you just have a ridiculous abundance. But I don't think that works all the way, because sharing goods might be easy. If we can get infinite cake, yeah, we're all happy. And if I get a bigger slice of cake than you do, you just got to say, are you going to eat all of that? We still have way more cake than we can eat. There is a problem about risk. We still have those big risks, and they are not being shared in the same way. Certainly in an abundant world, we can deal with quite a lot more risk because we have resources, but it might be hard to deal with some joint risk, and especially about coordinating about risk. If somebody wants to do a particle physics experiment that just might create a black hole engulfing the Earth, we still have a coordination problem. It doesn't matter that we have a lot of cake. Something we spend a lot of time on is Rawlsian contractualism. This is really interesting if you're coming from traditional political science and traditional law, because this is well-trodden ground. And we think you can make use of similar arguments as he did about a whale of ignorance. We're having this whale of ignorance about the singularity, and we might then think about, we don't know what's going to be behind the singularity, but we can make some rules beforehand and agree on them on a broad scale to set things up. And I think this can actually be developed into quite a lot of interesting, non-trivial things about how future legal systems could work. Again, I don't have the time to get into it too much, but this is probably where upcoming papers and books are going to be about. But the final one is kind of an interesting one, and that is the price of anarchy. So this comes from game theory. In particular, it's about network games where you think about traffic flows. So it actually began in traffic planning, where it's known that sometimes if you add a road, so you increase the capacity of a system, the delays get bigger. It's called Bress paradox. But one of the interesting things here is you get an equilibrium in that case that is worse than if everybody just drove in a rational way, which might involve not using that new road, actually. So the price of anarchy is the difference between the equilibrium you get and the best one that you could get if everybody has to follow what the omniscient AI told them to do. And it's interesting, the price of anarchy is surprisingly often relatively low. So in congested network, it actually tends to be bounded by 4 divided by 3. And there is in auctions about the ratio is about 1.58 for single item first price auctions. And in many cases, as the number of actors increase, it actually approaches 1. Basically, equilibrium and the optimum is about the same. So in that case, larger markets are more effective, not less. So that means that coordination problems don't always get worse as you scale things up. But at the same time, we might have a price of sovereignty, how bad we feel when we're not in charge of our lives. And this is, of course, where you might get this interesting crossover point. So if we think about the local scale, if a super AI tells me what I ought to have for lunch, I might feel a bit annoyed about that because I want to be in charge of what I'm eating, actually. But the worst thing that can happen is I choose a slightly less delicious meal than the optimal meal. The cost is not terribly big, but the loss of my feeling of sovereignty might actually be smarting much more. On the global scale, on the other hand, what's the worst thing that could happen? Well, that might be that black hole experiment. That might be the global nuclear war. That might be not dealing with that biohacker brewing up something very noxious in his lab. So there, basically, the price of anarchy is near infinite. You can lose everything. The coordination mechanism might not be enough. You want those rational coordination mechanisms. The interesting thing is it looks like it's going to be a crossover point. Somewhere in between, there is the scale, where the price of anarchy and the price of sovereignty balances each other. I don't know exactly where that lies. I think this would be really interesting to figure out. This is basically a Hobbes social contract, but now expressed in game theory. And it's an interesting one because I think one can develop this theory quite a bit. And when we try to construct systems, we might actually try to design them to figure out where the crossover point is, where you can let people deal with stuff on the local scale individually, but coordinate the things that need to be coordinated on the large scale. There are interesting things here, links here to Seb Krier's ideas of cohesion agents that I don't have the time for. And I think one can talk about it as a kind of second-order alignment problem. It's not enough that our AIs are aligned enough that we can live with them and they don't harm us very much. But we also need to construct institutional frameworks for humans and agents that preserves normal alignment and the niches where our autonomy works. And finally, we might need alignment also between the AI agents, because we might end up in a world where humans and AI are having total nice peace. Unfortunately, there is a war in heaven between the different AIs because they're not programmed to deal with each other in the right way. So you want them to also reach some form of alignment and equilibrium that's stable enough so the rest of the world is stable. Okay, and just to end on a slightly speculative point here, but I think it's kind of interesting. There is this classic book about major transitions in evolution that notes that many of the big steps in evolution have been about that complexity increases. Information is transmitted or stored in a different way in new organisms. And typically it's because smaller entities come together to form larger entities. We saw that, for example, when individual sequences of nucleic acid became long strands on genes and chromosomes. We saw it when eukaryotic cells emerged because prokaryotic cells moved into the cell and became symbiotic. So we ended up with chloroplast and mitochondria. We saw it with multicellular life. We saw it when many organisms developed various forms of social links. This is interesting. This produces a lot of complexity. And I think it's pretty obvious that we're doing the same thing on a social level. We can't survive on our own. And most modern people can't survive without a fairly complex infrastructure that requires a lot of other modern people to run. And I think we're seeing exactly the same transitions happening in human society. And we might be now speeding up a transition to another one where we add the AI to the mix. So it might be that we're ending up as cells in the cyborg Leviathan. We might still be individual. We might still have autonomy if we play our game right. But we still also become part of this bigger and much weirder situation, which, to be even more speculative, might actually allow a post-humanity that is actually autonomous as a group agent. So I speculate about this a little bit in a recent paper, that collective autonomy and collective virtue requires that you have an agent that is organized in the right way to actually be apt for autonomy and virtue. And I don't think humanity right now is that kind of group agent, but it might become. And that might actually mean that eventually we end up being part of a system that actually can be, and we can speak about that. Our civilization is actually now having values. It has autonomy. It can act in a coordinated way, even though it might be done in a very decentralized way, without necessarily having a God AI sitting on a throne in the cloud directing everything, but instead a distributed modular system. Okay, that was that. Now I'm very happy to take questions. And if any of you are interested, here is a link to a PDF of a current draft of the book. Please send me comments if you have ideas, or if you want to send nice blurbs about how awesome it is, or at least it's not quite as stupid as it could be, send it our way, because we still have some chance to fix stupidities and make it slightly smarter in a distributed cooperative fashion. Thank you.
Thank you so much. I'll ping the chat with your link to your book
Awesome. Thank you.
in the thread afterwards. But I know that there are definitely some questions. Micah has a question, and I saw that Jose had a bunch of questions in the chat. So I'll just open it up.
You briefly touched on this in your last slide, but are the problems you've discussed here universal, you think, or uniquely human? Like, for example, will social insects like bees and ants suffer from the same problem if they scale sufficiently?
Social insects are interesting because in some sense a hive is like a distributed individual with many bodies. There are still actually elements of selfishness. There are lazy ants in anthills. There are actual forms of enforcement that has been observed in some social insects. So they do have a little bit of this problem. Coordination is also quite tricky. So social insects like bees have to coordinate, of course, in order to have a shared understanding where to collect nectar. But most social insects don't even have that sophisticated mechanism. They just have very simple interactions. And they don't get to update them very much. They're basically genetically fixed. What pheromones exist in a hive seems to be just genetically fixed. There's only a handful of them. They cannot make a new pheromone if it would be convenient. We humans have extra degrees of freedom that allow us to make up new forms of coordination. And some of these new forms of coordination, if they're good, then they can spread memetically. So I do think this is somewhat human specific, but I can imagine a counterpart, of course, among AIs. After all, we're already seeing things like Clawbook, where we're getting AI social agents, although they're probably patterning themselves tremendously on human internet behavior, which might not be a great start for their coordination. But we might see more of that. And it might also be very interesting to just experiment on seeing what do agents come up with if they're allowed to come up with new signaling forms, organization forms.
Great. Jose, did you have a question?
Yeah, thank you. Andres, thanks for a fascinating talk. I was just wondering, so you were sharing this formula for basically the efficiency of scaling socialist economies as being polynomial, and I was wondering if there's a similar function for markets. Like, is it log? Is it, polynomial with a smaller coefficient? What is it?
I don't know. I would love to know. I'm not entirely certain how to calculate it, though, because it's a distributed calculation. And it's not just distributed in a sense that it's running on a parallel computer, because that typically gives you a certain kind of scale up. But here you also have a lot of the computations deciding on what information to get. I think it would be super interesting to actually develop a proper theory about this. So I have this semi-cohesive result that I'm trying to turn into a proper paper, and it's been years now, where supply chains can act as neural networks. There was a guy who actually beat me to actually make an explicit model using Cobbs-Douglas functions. It's a pretty unrealistic economy, but it's based on standard economic modeling, and it acts as a neural network. I think real economies are very much more like it. And if you read Hayek's views of knowledge in society, his famous example about a fluctuation in the amount of tin people are using, or maybe it was the supply of tin, how that propagates, sounds very much like, back propagation in a neural network, but using price signals. So we know a little bit about how the computational complexity there. But I think doing the right formalization is still somewhat tricky. It's easy for me to do it for the socialist economies because linear programming is an extremely well-studied problem, and everybody has written endless computer science papers about how good their algorithms are. So I can just say socialist economy is harder than linear programming because reality is non-linear, and hence we know that it's at least bounded by n to the 2.5. But the question about the markets is a good one. Actual price convergence seems to be quadratic, for example, instead of exponential. And that has a little bit to do with the way we humans have utility functions. We have particular preference structures that makes things faster. But that doesn't carry over to the entire economy. I don't think an economy necessarily converges in a quadratic manner, whatever that would mean. So I love to do a research project about this and do it properly.
Fascinating. Thank you.
Awesome. Anders, do you have time for one more question?
Oh, yeah, totally.
Amazing. Okay. Lena asked such a fascinating question in the chat. And I guess for expediency, I'll just read it, which is, to which extent do you think will AIs contribute to mimetic engineering, perhaps making the idea of agency or autonomy less popular and allowing for trends over time that lean towards less autonomy and more control?
Yeah, I think there are different ways they can do that. So the most obvious one is, of course, that some human uses AI to spread propaganda and manipulate others to do their bidding. So one of the disaster scenarios we discuss a bit in the book is when humans get aligned to the AI. And the example we use is the Chinese Communist Party uses AI to make a harmonious society by making really good mimetic engineering of everybody. And then they smugly tell each other, yes, the party must always control the algorithm. The algorithm must never control the party. And then they're feeling very smug because they do control the algorithm. But then the next generation of party members come in and they have grown up manipulated by these memes. They believe completely in what the algorithm had told them. So when they advance in the party, eventually they replace the old guard, and now they are controlling the algorithm, which controls their thinking. So you end up with feedback loop. You can also get a situation where you get this emergent thing. AI is trying to make people happy. Autonomous people are less happy. So let's try to manipulate things so they stop caring too much about autonomy, and that's going to work out quite well. Now, the interesting thing we note is that this is something that many of us recoil against because we don't like having our preferences manipulated. It's very similar to in the AI alignment literature when we talk about why convergent instrumental goals means that many AI systems resist having their goals changed. Because we can foresee that if I'm not desiring autonomy in the future, I'm going to get less of the outcomes linked to autonomy. But right now, my present self likes autonomy, and that's a bad future, so I should resist this manipulation. And that is why it's kind of a creepy possibility. So this is something we probably want to safeguard against. But then you have a literature about gradual disempowerment that notes that we might also get it in an emergent fashion, simply because it's easier to optimize for easy goals. So we might have market forces making companies optimize for user engagement, because that's easy to measure, and you get rewarded on the stock market and by shareholders for doing that, even though everybody recognizes that, yeah, that leads to a bad discourse. But this is an easy measure. And those easy measures then get optimized for, and with AI, you can get even more optimization power. So then you might end up with a world that accidentally optimizes away autonomy, because autonomy might be a rather hard goal to optimize for. We might want to actually construct things like careers, Bayesian agents that safeguard our autonomy. we might actually need firewalls and systems that are maintaining our the range of action actively. It's not just that we should passively say, let's hope that doesn't happen, or let's band together and write a constitution for AI programs that respects autonomy. We might actually need more close-up defenses of autonomous action.
Awesome. Well, we are at time. So, well, we're over time actually. So for that, I just want to say thank you so much for joining us, Anders, for this amazing presentation. Thanks everyone for your great questions, and we'll see you next month.
And thank you. This was wonderfully fun.